All right. Good afternoon, class. Um, so this is going to be a really easy lesson today. The topic of today's lesson is calculating the energy released in nuclear reactions. Energy is released. And so I'm looking it up, and I'm looking at polonium 210. So let's look at polonium 210-84. All right. So it decays. So I'm looking at the data in the back here in the appendix, and it says that polonium 210 decays via alpha decay. Okay, so it's going to spit out an alpha particle. Now, alpha particle has a mass of the half-life for that decay. Well, this unknown thing has a certain charge Z, and it has a certain mass number A. R equals 2 plus Z, which says that Z equals 82. All right. And so if you look that up, that element is lead. Okay. So the reaction that takes place is polonium alpha decays and becomes lead. And this isotope of lead is so this isotope of lead is stable. So there's going to be no more decays after it becomes lead. So how can we figure out how much energy is released? Well, I was able to look up the mass of polonium 210, and I found that it has a mass of 209.936784 atomic mass units. And I was able to look up an alpha particle's mass, lead 206's mass. So I was able to find the mass of the reactant, and I was able to find the mass of the products. So what is the total mass of the products? Okay. If I add those two together, I get 4.001506 plus 205.929482 equals, so the products have a mass of 209.93098. So the reactant is more massive than the products. Okay? So that means because the mass went down, that means that the amount of energy in these nuclei went down, which means that the energy was released. Okay? So if I look at the amount of mass that was lost and I subtract those two numbers, what am I going to get? Well, let me calculate it. So subtracting those, I get that the change in mass was 0.005796. So going to be the energy released, okay, if we convert it to energy. So the energy released in the reaction is going to be 0.00 electron volts or giga electron volts. Remember, 931.5 giga electron volts is equivalent to 1 U. So I multiply it by 931.5. Stream if you're interested. Okay, bye.